The next handout that should have been given to you are some sample applied problems. So we'll take a look at the even problems on this one instead, and then y'all can try your hand at the odd ones. So if you take a look at number 2, here's our applied problems. For number 2, we have find the hypotenuse of the triangle as shown in the figure. So this is pretty straightforward from the ones that we were doing. We are going to have x squared is equal to 8 squared plus 15 squared. So we have x squared is equal to 64 plus, my arithmetic is not the best, so double check my math, 225. And x squared is equal to 289, and when I take the square root of both sides, then x is going to be equal to the square root of 289, which is 17 meters for our hypotenuse. For number 4, we're finding the distance between 2 points, so I use my distance formula. D is equal to the square root of x minus x squared plus y minus y squared. So I have D is equal to 8 minus 3 squared plus negative 4 minus 8 squared, which is going to give me 5 squared, which is 25, and negative 4 minus 8 is negative 12 squared, gives me 144. And when I add those together, this gives me the square root of 169, and 169 is a perfect square because its square root is 13. For number 6, this is an indicative problem of what you'd probably see on an exam or a test or a quiz where it's just a right triangle problem, but they give it to you in words. So it says the hypotenuse of a right triangle is 68 centimeters. So anytime you're given a problem without a picture, always draw a picture. So we have a hypotenuse that's 68 centimeters. And the difference between the other two sides is 28 centimeters. Find the sides of the triangle. So if I call this side A and this side B, well, what I know is that A squared plus B squared has to equal 68 squared. And I also know that the difference of A minus B is 28. So you have a system of equations. So from here, I'm going to solve this one for A, which is going to give me A is equal to 28 plus B, or B plus 28. And I'm going to substitute this into my equation up top. So this is B plus 28 squared plus B squared is equal to 68 squared. So these are larger numbers. I'll double check my math before I write them down. So this is going to be 4624. Well, if I can write what I say. Here we have B squared. Now this B plus 28 squared, 28 times 28 is going to give me 784. So I'm going to have B squared plus 56B plus 724. So when I put all of this together, because now I'm working with the quadratic, I have 2b squared plus 56b plus 724 equals 4624. And before I do anything else, I'm going to divide everything by 2 to get rid of that 2 and make my numbers a little bit smaller. So this is b squared plus 28b I'm sorry, this should be 784 instead of 724. So plus 392 is equal to 2312, And then I'm going to set this equal to 0 because that's how I want all quadratics to be set up, equal to 0. So I'm going to subtract 2312 from 392. And this will give me b squared plus 28b minus 1920 equals 0. And so from here, what I would do is I'm likely, instead of trying to factor this, since the numbers are so large, I'm just going to put it into the calculator and graph it and see if I can find some intercepts that are nice and clean. And then if I can't find the intercepts that are nice and clean, then I will use the quadratic formula. But in this case, when you graph this, you are going to end up with a positive and a negative value, which clearly you can't use the negative value. And so what you're going to end up with is b is going to be equal to 32. And once I know that b is 32, and when you do that, you're going to graph it and look for where x is equal to 0. Or sorry, y is equal to 0, and you take your x values, and there'll be two of them. There'll be a positive and a negative value. And we can't use the negative value because we're talking about a length. And so if b is 32, then that means a is 28 plus that. So a is going to be 60. So b is 32 centimeters and a is 60 centimeters. For number 8, we have find the height of an equilateral triangle with sides 10 meters. So again, you have a problem without a picture, so we draw a picture. We have an equilateral triangle. My triangle is not drawn to scale, but we'll say that it's equilateral. And so we know that equilateral means all three sides are congruent, and I have sides of 10 meters. So what I do is I use what I know about isosceles triangles. If I drop a perpendicular from the vertex to the base, then I know that I have bisected the base. So that means I have 5 here. And to find my height h, I just use the Pythagorean theorem to do that. So I know that 8 squared plus 5 squared has to equal 10 squared. So I have 8 squared has to equal 100 minus 25, which is going to give me 75. So h is going to be the square root of 75, which when I simplify that down, h is going to be the square root of 3 times 25, and 25 is a perfect square. So I take the square root of 25, and this gives me 5 square root of 3 meters. And then for number 10, as our last problem, we have an arch is in the shape of a semicircle. Okay. And at a point along the base 1 foot from an end of the arch, the height of the arch is 7 feet. Find the maximum height of the arch.